let's look at how we can find inverse relations. If we're given a function f of x, we'll see how we can discover its inverse function, which we call this the f negative 1 exponent. It's not really a negative 1 exponent. It means it's the inverse function. That negative 1 there means the inverse function. So let's start with a function, f of x equals 4x minus 6. And we want to find what its inverse function buddy is. Our first step is to rewrite f of x as y. Remember, f of x is just a fancy way to say y. So we'll change the f of x to a y. Y equals 4x minus 6. Then here comes the key step. We're going to invert or switch x with y and y with x. We saw this with our inverse relations in a previous video. So what used to be y will now be x. What used to be x will now be y. And there's our new equation. Now we'll solve this new equation for y. We want to get y all by itself. That means we're going to add 6 to both sides and then divide both sides by 4. We've got it. Y equals x plus 6 over 4. And that may be good enough. You may be required to also then change that y to that f negative 1 thing to indicate that it's the inverse function. And you can write it like this. The inverse of f of x is x plus 6 over 4. That's really how you do it. Change the f of x to y, switch x and y, and then solve for y, and you will end up with your inverse function. In the rest of this video, we're going to check out why these inverse functions are interesting. So what is interesting about this f of x equals 4x minus 6 and the inverse of f of x being x plus 6 over 4? Well, let's graph them. You can see them on the graph, and at first it may not look very exciting, just two intersecting lines. But let's add the dashed line y equals x. Now if you tilt your head to the right 45 degrees, maybe you'll notice that these are symmetrical. When you have your head tilted at 45 degrees, the left and right side of that dashed line are the same. Here's another cool one. F of x equals x to the third power, and it turns out its inverse buddy is the cube root of x. If you tilt your head 45 degrees, you'll see the symmetry here and how the left and right sides are the same. It's like there's a mirror on y equals x. And then another one that we'll learn more about later in this chapter, logarithms. We haven't learned about those yet. They're coming. But if we look at log 2 of x and its inverse function buddy, 2 to the x power, if you, again, tilt your head 45 degrees and look at y equals x as a mirror, you do see symmetry. So that's one cool thing about graphing inverse functions, is they are always symmetrical with the line y equals x. What else can be interesting about inverse functions? Well, a way that we could kind of prove that they are inverse functions or to verify them is to plug them into each other, and we'll watch what happens. We'll start with the red f of x equals 4x minus 6, but I'll just write y equals 4x minus 6. And in the x spot here, we're going to plug in its inverse buddy, x plus 6 over 4. That's going to go right here. Well, these 4's reduce out to 1, so it's really x plus 6 minus 6, and we get y equals x. That was the equation of that dashed line. Well, that's when we plug the blue into the red. What happens if we plug the red into the blue? So again, I'm just going to write y equals x plus 6 over 4, and we'll take this red 4x minus 6 and put it in for x. And then we'll simplify. Well, negative 6 plus 6 is 0, so we really have y equals 4x over 4. And once again, we get y equals x. So there's lots of cool things that happen with inverse functions. And you can follow the steps we saw earlier. Change f of x to y, invert x and y, and then solve for y.